we'll see how various C programming language statements and expressions can be translated into instructions. A compiler may not literally implement an expression in the program. For example, the expression A less than B can also be evaluated as B minus A is greater than 0, or A minus B is less than 0. Which expression is best for instructions may depend upon the instruction set as well as the surrounding code. Compilers generate code that manage the stack for the function calls in the program. The stack pointer in RISC-V is known as SP. We can access an element in the stack using an offset from the stack pointer. In this case, we load register x29 with location that is 40 bytes away from the stack pointer. This example shows how a simple C expression can be implemented in RISC-V code. We load the two A and B variables, add them together, load C, and then multiply. An assignment statement evaluates the right-hand side and then stores the result relative to the stack pointer. The assembly language for an if statement can make use of labels to define the different components of the if. This assembly language first evaluates the condition and then decides whether to branch to the true part or the false part. An array is allocated as a block of locations. We can use registers as pointers in order to access elements of the array. We can also perform arithmetic to compute the address where we want to fetch the data in the array. The assembly language for a while statement tests the expression, and then if the expression is not met, it goes to a label corresponding to the exit. Otherwise, the body of the while is executed, and then the code jumps back to the expression. A struct defines a set of offsets for the elements in the struct. Since we know the size of all the elements of the struct at compile time, we can use fixed offsets relative to a pointer in order to access fields of the struct. To dereference a pointer, we can load the pointer into a register and then use it as an address to fetch the final value. The C programming language defines a for loop in terms of a while loop. The initialization expression, the test expression, the loop update expression, and the loop body can all fit into the while template. This helps us understand the assembly language for the loop. The code initializes the variables. It tests the condition. If the condition fails, then it exits. Otherwise, it performs the loop body, increments the iteration variable, and then jumps back to the start of the loop body. Functions use the stack to keep track of their state. Each function has an activation record on the stack. That activation record includes the return value, various parameters, information about the CPU status, some local data, and some temporaries. Thanks for watching.